Thank you, everybody who joined this urban panel. We're going to be starting in a minute. Hello, everybody. Thank you for joining. This is the urban panel on smart metering. It's 10:30, so we're gonna jump into it. My name is Steffi Becking. I'm one of the California Irrigation Institute board members. Jenna Schimming, a fellow board member, and I will be moderating this panel, and we hope you enjoy it. Big thank you to our sponsors for supporting this conference. Our platinum sponsors, Metropolitan Water District of Southern California and CoBank. Our gold sponsors, Water and Land Solutions and Yosemite Farm Credit. Big thank you to our silver and bronze sponsors too. We greatly appreciate your support. This conference really is not possible without this additional support from all the sponsors. So thank you so much. We will start this session with presentations from two of our sponsors, Badger and Ewing. If you have questions on the presentations by Badger or Ewing, post the questions in the chat. The presenters are monitoring the chat and will be happy to address your questions. So with that, let me start the first presentation.
Is your water utility looking to make that jump into the world of AMI fixed networks? Are you confused about all the technology choices available to you, from traditional data collector-based systems to mesh systems and now cellular technology? Well, in this video, I'm going to review 4 key reasons why cellular might just be the right technology choice for you. Let's dive into it. Welcome to the Smart Water Show, brought to you by Badger Meter. I'm your host, Maurice Blackwell, and this is the show where we talk about your day-to-day water utility problems and then find the right solution for you. Traditional data collector-based fixed networks have been around since about 1996 for water utilities. They've come a long way in the last decade, going from daily information to hourly information and now even 15-minute interval information. These systems provide great efficiency gains from leak detection to customer service to meter reading. However, the complexity and cost of traditional data collector-based fixed networks have held back some utilities from making that jump to the next level of technology. Cellular solutions have really become a true viable solution for utility, just simplifying the whole deployment approach. With a cellular system, I'm deploying endpoints that speak directly to the existing cellular network. I sort of unburden the system from the complexity that it is the data collector. Over my 26 years in the water utility industry, I have spoken with hundreds of utilities that are looking to justify making that next technology step. I'm going to share with you some of the stories that I've heard from utilities over the past 5 to 6 years that have made the choice to move towards a cellular technology versus a traditional data collector-based system. I think once you hear some of these stories and understand why these technology decisions were made, you and your utility are going to be better equipped to figure out what the right technology fixed network is for your water utility. And as an added bonus at the end, I'm going to share with you a link where you can download a white paper that really goes into an expansive detail of the things that we're going to talk about here today. Point number 1, simplicity. Like with anything in life, there's an easy way and there's a hard way. Deploying a cellular system is like sort of hitting the easy button. Another way that it could be said is, I could have 20 endpoints this morning that I wanted to deploy on 20 important accounts. I could deploy those in the morning, and then this afternoon, I could be getting in the valuable metering data for those accounts. It's just that simple. Sometimes people compare a cellular deployment to even a mobile deployment, but I think it's even easier than that. Because with a mobile deployment, someone's got to load the routes, someone has got to load up the equipment and put it in the vehicle and go out and read. With a cellular type deployment, I don't have to worry about any of those things. It is the simple approach. Point number 2, cost savings. When you're doing the analysis of the cost savings of a system, you need to truly look at the 20-year life cycle of a traditional data collector-based system. Part of that equation is the installation, purchasing, maintaining, and managing that system over the full 20-year life cycle of the system. There are things that come into play, either repairing those things along the way and replacing them. Let's talk about repairing them. Most utilities today probably do not have the personnel within the utility to truly take that job on. Do you have someone within your utility that can climb your water tower or climb a radio tower to do a repair of those data collectors? Do you have someone within your utility that has the RF knowledge that you need in order to troubleshoot issues that may be going on? Or are you going to be beholden to a contractor to take care of those things for you? The second part of that is the replacement. You also have to put in that 20-year life cycle the replacement of the data collectors. The data collectors don't last the full 20-year life cycle of the system. Most manufacturers will tell you that you need to replace the data collectors once, if not twice, over the 20-year life cycle of the system. So when you take that into account, it can be quite costly over that 20-year life cycle to maintain that network yourself. Point number 3, flexibility. If you are a manual or a mobile read system today, there's 3 scenarios where I see that you can utilize the cellular technology. One would be for your largest accounts. Maybe you want to get more information on those large accounts to see if those meters have stopped, to be able to monitor those meters, or even supply that information to those end customers. Secondarily, there may be accounts that are on the outskirts of your service territory, maybe accounts that you've annexed in that takes you a long time to drive to. Those are accounts that you can deploy the cellular technology and then not have to get to. Lastly, I see utilities that are looking to deploy technologies that have sensors built into them, like meters that have pressure or temperature built in, or maybe flow restriction valves built in. Deploying the cellular technology, you're able to deploy those particular types of sensors or valves within your service territory wherever you want to deploy them and still have that level of control. Lastly, I see utilities that have traditional data collector-based fixed networks utilizing cellular technology in a couple of ways. One utility was a very large utility here in the United States, had deployed a traditional data collector-based system. I ran into this individual at a particular trade show, and she came up to me. She was very excited. She said, "Hey, I love your cellular technology." And I says, "Really? I thought you had deployed, a different type of network." She says, "We did, but we are a wholesaler that sells water to utilities that are hundreds of miles away from our city, and there was no way we were going to be able to deploy that type of technology for those wholesale accounts. So we chose to use the cellular technology, and it was very simple to do." Point number 4, service level. There are 2 ways to purchase a fixed network. The first one is supply and install. where you, the utility, are responsible for purchasing, installing, maintaining that system for the life of the fixed network. The problem is most utilities don't have the expertise in-house to do those things. One, to do the installation. Normally you're hiring a contractor to do that. Two, someone there within your utility to make the repairs that are needed throughout the life of the system. The last part of that is changing that system out. As we talked about earlier, most fixed networks don't last for a period of 20 years. If the data collectors need to be replaced, you, the utility, are going to be responsible for doing that. The second way to purchase a fixed network is under a network as a service contract. What this means is the manufacturer is now responsible for installing, maintaining, and managing that fixed network for the life of the system. It's one less thing that you need to worry about. The beauty of a cellular deployment is you have the major telecommunication companies now responsible, basically working for you to keep that network up and running. This is probably the safest way to buy a fixed network, and you can buy a traditional data collector-based system this way or a cellular system this way. But this is what I recommend for most of my customers. If you'd like to delve into this topic even more, I've put together a free white paper that you can download by going to badgermeter.com/Smart Water Show and search for episode 1. This white paper goes over the 4 points that we talked about here today, as well as a few bonus points. If you have any questions about today's topic, feel free to ask a question in the comment section below. I'd be happy to provide you with an answer. Or if you'd rather send a private message or have any questions related to metering or meter reading systems, be sure to connect with me on LinkedIn. If you found this content valuable, be sure to click the like button. Stay tuned for next week's episode where we will discuss how to get your customers to stop calling about their high water bill and take ownership and responsibility for their usage. We'd like to thank you for watching this video, and we'll catch you next time on the Smart Water Show.
Hello, everybody. If you have just joined us, welcome to the Urban Panel on Smart Metering. My name is Steffi Becking. I'm co-moderating this panel along with Jenna Schimann. You see her picture in the, and here she is waiting. You'll see her in a little bit. We started this session with the presentation from Badger, and now we will move on to the presentation from Ewing. If you have questions on the presentations by Badger or Ewing, post your questions in the chat. The presenters are monitoring the chat, and we'll be happy to address your questions.
Hello, and thank you for your attention. This is Raul Gonzalez, and I would like to thank the California Irrigation Institute for the opportunity to present to you a brief overview of one of Ewing's most recent webinars, some information regarding our mobile and web technology, as well as one of our current sustainability efforts. Ewing Irrigation and Landscape Supply is the largest family-owned national supplier of irrigation, landscape, agronomic, outdoor living environments, and water management products, with over 220 locations in the nation, including 55 in California. We strive and pride ourselves on providing the best possible customer service and resources to the green industry. Ewing works diligently to be the premier education and most viable business partner to all industry professionals. Most recently, our normal in-person training was morphed into socially distant live presentations. Via our education portal, there is the availability to view over 30 previously recorded sessions in a large myriad of topics, or on Ewing's YouTube channel, which includes an extensive library of how-to videos including various topics in Spanish. So first, I want to give you a brief overview of one of our most popular topics recently presented as a live web Zoom webinar. Understanding basic hydraulic skills for design, installation, and troubleshooting in the landscape irrigation system. Understanding basic hydraulic skills was a 4-hour, 2-part presentation offered for CEU credits for various national, state associations, and some state licensing agencies, providing information solutions that can help someone become more skilled and proficient in the landscape irrigation field. In our years of helping professionals out in the field, we are sadly confident in stating that many irrigation systems struggle due to pressure-related problems, both low and high pressure. We're also very confident in saying that in many cases, this is due to the lack of knowledge, lack of understanding, or the lack of the proper tools to diagnose the issues. Systems low pressure or improper maintenance will waste water because in many instances, the typical solution is to increase the runtime, hoping that capillary action will magically solve the problem. Conversely, overly pressurized systems that are not regulated will perform poorly as well due to wind drift and evaporation. Diagnostic tools are rather inexpensive, but that investment is seldom done. These items are seldom purchased or seldom used. The importance of understanding and the management of water pressure as it's delivered to the critical sprinkler, the last one in the largest zone, is extremely important in the design, installation, and troubleshooting of a system for optimum performance and efficiency. Static pressure is very important, and knowing where to obtain the information starts the evaluation process. Knowing that the working pressure will more than likely drop as the water is being delivered to the sprinklers, one must know what is an acceptable pressure loss and what it should be for proper component sizing and design. In part two, we discuss the importance of understanding actual flow measurements and the proper pipe sizing for installations and renovations. The basic understanding of the measurement of the actual flowing volume of water through the water meter and the potential of converting cubic feet to gallons per minute is crucially important. The lack of these skills will create issues when the water supply does not match the actual field requirements. So flow tests will help avoid future headaches. Understanding the relationship of the parameters that must work in conjunction with the system to achieve efficiency. In other words, that relationship is crucially important to get the most of your irrigation system. Water pressure is created by a force of gravity on a column of water or mechanically increased or generated by a pump. The irrigation system typically provides accessible test points that allow a technician to gather the information regarding existing pressure, but understanding the relationship between static and dynamic pressure is key for a systems evaluation. We present the tools and techniques for establishing a successful system or renovation, including the proper pipe sizing based on the actual and expected flow in order to avoid wasted time and resources. Because the pressure can be a big issue in destroying the irrigation profile and efficiency of spray heads, the most commonly used landscape sprinkler device. Some states, including California, found it imperative to implement the pressure regulating spray body ordinance. The basic understanding of these principles are presented in a lot more detail, including some real-life examples of area measurement and water applications relative to water costs. So ultimately, recognizing and understanding the volume-pressure relationship is really the most basic knowledge that any landscape irrigation professional technician must have to achieve a skill level of proficiency. The more you know, the more you're worth. It's not just what you know, it's what you can communicate. Another valuable tool that Ewing has available is the recently updated mobile app that operates on both iOS and Android systems. And best of all, it's free. You can use it just to find viewing locations in your region, providing directions, store hours, and contact information, but you will get the most out of it using the Tools section. Under the Irrigation tab, by simply plugging the key information, it can be used to quickly and accurately calculate the precipitation rate of your sprinklers or drip system, as well as the station run time based on the plant or turf requirements. 3 important elements that you must have in order to be able to accomplish this is the sprinkler spacing and the flow of the irrigation device you're using, the landscape plant water requirement in inches per day, and the irrigation desired frequency for water replenishment. This information, the ET information, can be found at CIMIS, California Irrigation Management Information Systems in California, where you can drill down a specific section. I'm looking at San Diego over the course of the year, and this specific weather station would give you the information in various months. We're looking at June, one of the hottest months of the year, and it tells you that the reference ET is 4.97 inches, but the reference ET, because we're using cool season turf in their particular example, would only be 70% of that, or 3.48 inches, that need to be replenished over the course of the month. Knowing that June has 30 days, the replenishment requirement will be 0.12 of an inch per day. So good practices would tell us that we are not going to water every day, and more than likely we're going to water every 3rd day. And so therefore, that 0.12 of an inch multiplied times 3 would tell us that every time we would water, we would need to replenish 36/100 of an inch. Now we can use that mobile app to get that information, to be able to plug in that information and get some the information that we're going to use to program our controller. You can refer to the catalog where you can find the optimum conditions. In this case would be for a 15-foot spray head, would give you the flow, would give you the precipitation rate. But in most cases, is the actual sprinkler spacing that the catalog specs typically do not meet the actual installation conditions. In our example, 13 foot by 13 foot for a 15-foot radius will result in a much higher precipitation rate. But with that information plugged into our app, it would tell us that if we had those conditions, 2 inches per hour, a little more, every day that we would water, in this case, every 3rd day, we would need to water about 10 minutes a day. However, we also need to take into consideration what type of soil we might be applying the water to, and knowing that we may have to split that watering time into 2 or 3 cycles. The other major factor that must be considered is the actual efficiency of the sprinkler zone that you're trying to irrigate. The most accurate method of achieving this would be to perform a physical water audit. But if that's not available, the manufacturer's performance literature is a good start. But perhaps also helping is the knowledge and keeping that even under the best conditions, a spray head system is typically around 60% efficient, and a rotor system would be or would have around a 70% efficiency. With those factors, we can then plug in those numbers back into our app. In this particular case, because we have clay soil, we decided to use the MP rotator, lowering the precipitation rate. And by pressing the calculate button would tell us that we would need to water 49 minutes every time that we would water, every 3rd day in this case. But we do have to keep in mind that our system is never 100% efficient. We are taking into consideration that we're using MP rotators, therefore having to bump up our watering time, where a result of almost 60 minutes a day. We should do a visual observation so as to not exceed the maximum runoff time and waste water, and typically 12 inches in clay soil, but doing a visual inspection is the most accurate method. The app can also be used for calculating fertilizer applications, as well as doing some accurately determining irregular areas or different shapes that we may encounter in the landscape. The other feature, you can find all the latest and greatest news at Ewing or in the industry. But most importantly is that it's free and you can carry it in your tablet, on your phone at any time, for access at any time. The other initiative that I want to talk to you is one of sustainability. Ewing has been promoting for the last few years one that until recently was an exclusive partnership with a major irrigation manufacturer and Blue Star Industries, an organization that employs folks with disabilities to dismantle electronics in order to recycle or properly dispose of the potentially hazardous components in a discarded sprinkler controller and keep them from contaminating our landfills. With this program, anyone can go to any Ewing branch and drop off any brand of irrigation timer so that it may be sent to Blue Star for its proper disposal. And best of all, it's no charge. Ewing Web's portal has been online for more than 20 years, currently providing you with an advanced search engine that gives you access to real live inventory, ability to create orders, check history, check status, and pay on your account, among many other features. So this and much more information and resources are available at ewingirrigation.com or directly at ewingeducationservices.com. So whether you're looking for professional resources via in-store, mobile, or online, and hopefully sometime in the near future back to in-person education, please consider Ewing as your premier supplier of choice. We would love to have the opportunity to earn your business. Do please contact us directly at any of our 220 locations, by phone or online, so that we may find a way to assist you. Do please stay healthy, please stay safe. We thank you for your attention and certainly for your support.
Thank you, Maurice and Roel, for your presentations. If you just joined us, I would like to welcome you to this panel titled Smart Metering, the Good, the Bad, and the Ugly. My name is Steffi Becking. I'm co-moderating this panel along with Jenna Schiman. Just 1 second. All right, and we are ready to jump in this panel. We have 4 fantastic speakers on this panel: Don Schlenger with Don Schlenger and Associates, Greg Lauritsen with Marine Municipal Water District, William Granger with City of Sacramento, and Debbie Figoni with City of Beverly Hills. Don will give us an overview on smart metering in urban sector. Greg, William, and Debbie will provide insights on using smart metering in their specific jurisdictions. Each speaker will have a 15-minute presentation, and at the end of all presentations, we will have time for Q&A. Feel free to post your questions as they come up in the Q&A module. That way it will be easy to track all the questions, and you can use the chat to post comments and reactions. The speakers will be monitoring the Q&A module and the chat throughout the session. Note that the session is being recorded. The link to this recording and the recordings of other sessions will be mailed to conference attendees. So if you are a little late or missed a portion of a panel that would have liked to attend, you'll have a chance to listen to that. Now, with the logistics covered, let me introduce the first speaker, Don Schlenger. Don already presented at the joint session, so you might have heard the intro, but for people that just joining for the urban portion, I'm gonna reintroduce Don. He is an expert in customer service technology and processes with more than 40 years of experience in utility management and consulting. He's an internationally recognized expert in advanced metering infrastructure, AMI, a former utility executive. He founded and served as the first president and executive director of Utilimetrics, the Automatic Meter Reading Association. Don has helped many utilities with AMI business cases, procurement, and implementation. That's his element, AMI, AMR. For the American Water Works Association, Don chaired the Customer Service Committee and the Customer Metering Practices Committee and served as a member of the Technical and Educational and International Councils. Don was principal investigator of the Water Research Foundation study titled Advanced Metering Infrastructure, Best Practices for Water Utilities. He also authored a guidance manual for water utilities on advanced metering infrastructure, and that guide is distributed by the Alliance for Water Efficiency. Don holds a master's in environmental engineering from Johns Hopkins University and a PhD in environmental sciences and engineering from the University of North Carolina. We are very excited to have Don open this panel with his presentation. The bottom line from the introduction is that he is an expert on this topic. So if you have any questions on AMR, AMI, Don is the person to ask. So I'm gonna turn off my video and audio and start his presentation. Hang on a second.
Good morning. I'm going to talk a little bit about navigating AMR and AMI options, and in particular, more about advanced metering infrastructure. I'm going to review the technology a bit, some technology and market trends. I'd like to discuss a few of the challenges facing utilities, particularly those that already have some metering technology. A few words about feasibility studies, planning for a project, and finally, a little bit about the business processes and policies that should be put in place to ensure the project is successful. Many water utility organizations are at different points along the path to a new metering system. AMI tends to be an elaborate undertaking incorporating several major stages. In this short time, I'm going to skim across a variety of topics which probably won't be satisfying for some of you, so I apologize in advance. It's always exciting to hear what utilities are doing with their metering systems, and I'm leaving much of that discussion to the other panelists following me. But it's important to understand the foundations of these successes, so there's a few areas I want to cover. First, a few words about automatic meter reading, mostly drive-by. It's still a viable technology. There are several vendors that offer AMR. Some utilities are already on their second or even third AMR systems. A nice thing about AMR is that you can get a reading. If you can't get a reading, just get closer. You don't need a network and fancy software. But AMR systems enable you to look back at consumption from the current billing read, while AMI enables you to look at consumption leading to the next bill. Therefore, it's more powerful. And a dedicated fixed network adds about 15% of the cost of an AMR system. Of course, as you imagine, there's more to it than that. An AMI system consists of a radio called a meter interface unit installed at or in the meter, a neighborhood data collector to pick up the signals from that radio, and some sort of backhaul to a server which collects and stores the data, a database system to take care of it, manage it, and interfaces to the billing system, a portal for customers, and perhaps other applications. I try to be vendor agnostic, and in this picture I've shown equipment from different vendors, even though those units don't necessarily talk with each other. By mainstream, I mean that perhaps 60 to 70% of all the water meters in North America are on either AMR or AMI, although we can't always tell which is which because the radios can be used sometimes in both modes. Most AMI systems produce hourly reads from each meter, and that's almost 9,000 readings per year per meter. That's a lot of data. However, many utilities underutilize that data. A little bit about technology trends. Most of the new meters that are available have electronic registers as opposed to mechanical, which allows them to be smarter. There's an increasing purchase of ultrasonic and magnetic water meters, and some of the meters provide pressure and temperature, and you can also get those sensors talking directly to the radios. A few vendors have remote control valves, and with all this, the software is getting increasingly sophisticated, including artificial intelligence and analytics to discern more about what's going on at the customer's premises. Of course, cybersecurity has become a big issue, and all the systems have stepped up their security. We're also seeing the advent of more open networks, such as LoRaWAN and cellular, and new communication technologies related to the Internet of Things. I've somewhat arbitrarily split technology and marketplace trends, and these aren't all the trends. But the point is AMI technology is evolving faster than water utilities typically upgrade their systems. That means that many utilities will live with technologically old and even obsolete equipment. Also, since water meters are now smarter, they are less of a commodity product and sometimes less interoperable with AMI systems from competing vendors. LoRa stands for long range, and NB-IoT stands for Narrowband Internet of Things. Perhaps the biggest shift in the marketplace is to service models in which the data is collected in the cloud. This is known as software as a service. Vendors are also offering network as a service in which they take care of, own and operate perhaps the network. The ultimate point is meter reading as a service in which a third party is really responsible for simply providing meter reading data to the utility as needed. Some of the AMI companies have been acquired by large conglomerates which can provide integration of applications and many more resources. Over time, I expect more utilities will gravitate towards meter reading as a service. The AMI market is still growing and new entrants are coming in. At the same time, the market is maturing. This gives a utility more choices. AMI is still relatively expensive, and if it's only used for getting reads for billing, it's going to drive up costs and raise rates for certain. Basically, it requires and enables major process and policy changes to be effective. Unlike some other infrastructure investments, it's possible to show payback from AMI. But AMI systems have to last 15 years or more to be worthwhile. And this need for longevity versus the changing technology presents challenges to water utilities. Moreover, if you already have some metering technology, then you have the additional challenge of a quote-unquote brownfield procurement. Some utilities already have a mix of technologies. They might have automatic meter reading in some places, touchpad in others. Sometimes they're geographically interspersed. For example, the utility might have put a radio on a meter when it was changed, or replaced failed components on a piecemeal basis. This might be called opportunistic deployment. Since the technology is evolving, you can't buy an old model radio anymore, you have to buy the current model. And according to one study, system transition starts around 8 years, which means that if you have a system that's supposed to last 15 years, you're going to have more than one model. In this example from a utility in Texas, you can see the interspersion of different models of Itron, AMR, and AMI units. Mixed technology hurts efficiency and raises cost. Meter readers have to carry a lot more equipment. There are lost economies of scale. They'll read one house and walk past the next one. Different meter resolutions offer different levels of service to customers, and are a nuisance for customer service reps, field, and IT staff. Look at the meter reading routes for the utilities shown on the lower left. Green is manual reading with a handheld, red is touchpad, and purple is AMR. The meter reader is actually less productive. Let's suppose you've already captured a lot of the benefits of AMR, reducing your meter reading staff. So that savings is not on the table anymore if you want to upgrade to a new system. You've already replaced your very oldest meters, so you can't make money changing the rest. If you want to upgrade, some of your equipment will be replaced before the end of its service life. Is that justifiable? This leads to another question. Should you bother with a business case? Whether it's for a new metering system or a replacement, more and more utilities are not bothering. They say it's too expensive, takes too much time. They're simply putting AMI in the budget. By the way, you can get economic benefit cost templates from vendors, from other utilities, and from the internet. You don't have to spend much money. However, you do have to populate the template with your data, and that takes time and it takes work. With the feasibility study, you can develop an idea of what your system will cost and what you can expect to save. And you can use the study to create involvement and commitment with the different players in your organization. By its nature, the feasibility study or business case requires you to quantify savings as well as costs. One thing we've noticed is that savings can be significant, and often nobody believes that you can get significant savings until you show them how. In these examples, there are workload reductions on the order of 60% or more in meter reading, in field service, in investigations, and there's other reductions in things like courtesy adjustments. Here's a list of some of the major benefit areas for AMI. You can read the list on your own. I'd like to point out there's some straightforward ones like reducing meter reading staff, and there's some other ones that are a little more complicated like deferring capital construction. Many of these benefits can be quantified, like meter reading savings, but others, like customer confidence, obviously cannot. Some are straightforward and others not. There's kind of a hierarchy of benefits. Tier 1, for example, includes things like meter reading and billing and final reads. Tier 2 involves process design, for example, soft disconnects. Tier 3 is, if you will, fancier stuff like personalized budget rates and irrigation management. Proactive leak detection falls somewhere between Tier 2 and Tier 3, if you will. And this is key. The more complex and strategic the benefits, the longer it's going to take to establish them, both in the business case and for real. People tend to think about an AMI business case as just a benefit cost analysis, but it's got to be more comprehensive than that. It should also touch on things like intangible benefits and costs and an assessment of risk, as well as organizational readiness. For example, should the utility wait until the meters are older and need to be changed before undertaking AMI? Is the organization ready for an all-hands-on-deck project, or does it need a new billing system first? Is the manager of customer service about to retire? All these things should be incorporated into a good feasibility study. There's a lot to be said about procuring an AMI system, developing RFPs, negotiating contracts. There's not time to talk about that in this short presentation. So I'd like to jump over to AMI project management. It's a complex project involving procurement of product, developing of information technology interfaces, communicating with customers. There are many aspects of the project, each of which requires, if you will, its own plan. Even if you have a turnkey deployment where the vendor does all the installations, you still have to manage a multifaceted project. You can look at this list, but I want to point out one item, the application roadmap. A project manager for AMI once told me the real project began once all the meters were in. And in developing applications and rolling them out, It's not advisable to do everything at once. For example, your customer service staff should be really comfortable with creating and interpreting consumption graphs before you start with automatic leak notification. The AMI system is your cash register, and it's also your major interface with customers. So operating and maintaining an AMI system is very important. Sadly, some utilities have neglected their investment, and the result is that the system degrades. If you have a dedicated network, for example, system performance might degrade over time simply because of the growth of vegetation and buildings. The usual problems are because the original AMI staff and executive have moved on, and the project becomes more or less orphaned. So you've got to make sure there are 3 people that have job responsibility for the AMI system. Someone to watch over the physical system on a day-to-day basis and make sure that maintenance gets done. Someone to watch over the data and the software, and someone to watch over the users. That includes the customer service folks as well as customers. Let's talk about leak notification as one of the more interesting applications of AMI related to changing the customer service experience. There are great stories about this, but if you're going to do leak detection and notification, particularly if you're going to notify customers proactively, there's a lot of things that have to be put in place. You need customer contact information. You need rules about how often you're going to contact customers about leaks. You need to follow up and make sure they're fixed. You need some diagnostic tools, and you need to know a little bit more about customers. For example, if a customer has a humidifier, they will pretty much always show a little bit of consumption around the clock. Everybody talks about proactive leak notification, and it's a powerful tool. But from my experience, customers don't want raw data, and they don't want complexity in looking at their consumption. They want early notification of problems, a potential diagnosis, for example, your toilet flapper is not closing, and solution options, and they want privacy. They don't know from CCFs, they want to know about dollars and gallons. So if you're going to do it well, you need these and other items. Another important area that needs to be thought about generally before the project starts, and certainly before a lot of things are rolled out, are the policies needed to ensure effectiveness and fairness with customers. With AMI, you're going to have a lot of data, and customers will expect you to use it. Every utility should probably develop or modify a set of policies to set expectations for itself and for its customers. To the customers, for example, if you want to be notified of a leak, then you've got to give us your cell phone number or an email address. We'll give everybody 5 days for courtesy leak adjustments, but if we don't have your contact information, we can't do it for you in a timely way, and therefore we may not allow you to participate in a courtesy adjustments. Another important area is rental properties. Ideally, a utility should require and enforce third-party agreements between the landlord and the tenant, and if the tenant doesn't pay the bill should be reverted to the landlord. With AMI, you've got to make sure both the tenant and the landlord are informed of leaks, because it's the landlord's responsibility to repair them, even though the tenant may be paying for them. Another policy I recommend is that someone should always be on the account. No one should be able to simply retire from the service without the move-in information for another customer. With AMI, you have a meter reading on every day, so you know who owed what on the day the property closed or was transferred. Lastly, a blatant sales pitch. We've created a guidance manual for water utility managers, and it's available from the Alliance for Water Efficiency. You can go to their website or you can call them. We've collected the experience of AMI and AMR project managers, consultants, and vendors for over 40 years and put them in a fairly easy to read but comprehensive manual. Thank you for your time and attention.
Thank you so much, Don, for this informative presentation. I live in SoCal and just have a personal story to relate to this presentation. My water provider is small and sadly does not have AMI deployed. Just 2 days ago, I received a water bill for $500 that's covering just 2 months. Normally it's a $100 bill. And so it's a leak that was on for too long. So I just so wish that this utility had a customer portal and the early leak detection service that Don is talking about. Now with this, I'm going to turn the mic to my co-moderator, Jenna Schiman. Her video, I think, is starting up. Any minute, she's gonna facilitate the rest of this panel.
All righty. Thank you, Steffi. Can you see me now? Hopefully.
Yeah, we can see you and hear you. At least I can.
Right. Bring up. Great. Great. I just wanted to bring up a little slide to show what each of the 3 agencies that I'll be sharing their presentations, how many connections they have and how many endpoints they have, what kind of meters and customer portal that they're using. And so the first one is going to be Craig Lordson with Marion Municipal Water District. Craig has been a water conservation specialist with the Marion Municipal Water District, MMWD, for over 10 years and is a certified landscape irrigation auditor and a water use efficiency practitioner. For the past 7 years, he's been involved with MMWD's landscape plan review and WELO process. He has a bachelor's degree in environmental studies from Sonoma State University, and Craig was recently promoted to meter operations supervisor. And with that, I will get his presentation up.
Hello, my name is Craig Lordson, and I am the Meter Operations Supervisor at Marin Water. This presentation is about the findings from installation of AMI on our irrigation meters. The agenda for this presentation includes some background on our AMI project, AMI on our irrigation meters, a few leak examples, and some takeaways. On this slide, you can see our service area. We're located just north of San Francisco, and we serve over 190,000 people in central and southern Marin. We have over 62,000 connections. Here's some background on our AMI project. Our install started in late 2017 with the help of grant funding from Irrigation.
Jenna, it's fine now. It was blurry, but it got better.
Okay, great. Thank you.
No problem.
Here's some background on our AMI project. Our install started in late 2017 with the help of grant funding from Integrated Regional Water Management. Our initial project included about 750 dedicated irrigation meters. Since then, we've expanded close to 5,000 meters. The expansion has included residential, business, and institutional meters. We are using the beacon system with cellular endpoints. Most of the meters involved have either been retrofitted Census SR2 meters, in which we attached digital registers to connect to our cellular endpoints, and we've also installed lots of Badger E-Series meters. We are using Ion Water as the customer-facing portal. In 2020, we concluded a feasibility study using the services of Don Schlanger, who is also presenting at this conference. We learned a lot going through the feasibility study process. I worked closely with Don, and we essentially looked under the hood of our meter infrastructure, meter population, looked at the makes and models and ages of what we have in the ground. We considered a few different vendors and looked at their product and their system. We looked at the complex topography of our service area, and we really got down to the nuts and bolts of the cost and benefit of going full AMI. Now I'm going to talk about AMI on our irrigation meters. These meters serve parks, golf courses, school landscaping, HOA common areas, business landscaping, street medians, etc. It's important to build relationships with these users early on as you're trying to roll out a new AMI system. Now you may have pre-AMI relationships already, which is great, but you want these irrigation customers to experience all the benefits of AMI, just like the water provider is trying to do. Now, an important part of that relationship is the customer portal. We've been tracking signups for the last 3 years and looking specifically at those 750 irrigation meters. We've passed up the 50% mark of irrigation meters that have an associated customer portal. You can see that in the first year, we gathered most of the low-hanging fruit with signups, and since then, there's been a slow and steady climb to get us to that 50% mark. Now, most of the recent signups have been from folks that got a high water bill or a leak, and then they find out that by setting up this account, they could have found out about the leak a lot sooner, and that's usually enough of a nudge to get them to sign up. Now, it's helpful to track efforts and leak data along the way so you can find out what works and what doesn't. We were motivated in part by grant reporting requirements, but we also wanted to just kind of learn as we go and track our progress. So we created a access database early on that we feed the water use data into, and that generates letters once a week that we mail out to customers with leaks over certain thresholds and to customers with high water use patterns, meaning their recent water use is higher than the 2-year average. So there's the weekly letters. Through this process, we've made over 1,100 customer contacts. This is just for the 750 irrigation meters. And in addition to the letters, there's also phone calls and site visits, emails to notify people of leaks and high use. And across all of the leaks we found on these irrigation meters, the average is about 3,000 gallons per day. We've also been tracking what we call large leaks, which we defined as leaks over 3,000 gallons per day, which works out to about 2 gallons per minute. And sometimes these leaks last 2 or 3 days, sometimes 20 or 30 days. But compared to a 2-month period, as most of our customers are billed bi-monthly, and it's often the high water bill is the first time a customer finds out about a leak. So to get that down to a 10-day duration has been pretty impressive. And the average water savings on these large leaks is about 350 gallons. And how we determine that is we assume that the average leak would last about 45 days without AMI, and we subtract how long the leak actually lasted, because we can easily see the leak using the AMI data when it started and when it stopped. So we take the 45 days minus how many days the leak actually lasted, multiply that by the average gallons per day of leak, and that's how we come up with our water savings. All right, I've got a few leak examples, starting with number 1 here. This leak occurred back in 2019. It actually started the night before on April 8th, but I have the hourly data for April 9th laid out here. And you can see the leak started out relatively small in the early hours of that day, and by the end of the day, it peaked at 31 gallons per minute. Now, if you take that 31 GPM and spread it over 24 hours, that would equal over 44,000 gallons. Now, this leak turned out to be a failed glue fitting on a PVC irrigation line. The leak actually stopped the next day on April 10th. So when I saw this leak in our water district facing portal, I called the number associated with the account and spoke with someone there. They said that they would send out some maintenance staff to investigate. I also went out and did a site visit and met the maintenance staff out there. And when we turned off the irrigation backflow, the meter stopped, but we went ahead and left it on because we wanted to walk around, see if we could find the leak. So this was had some minor irrigation areas, but essentially a lot of it was just kind of unmaintained. And after walking around for a while, I was passing through this unmaintained kind of shaggy field and heard some water bubbling up from the ground. And there wasn't any paths or sidewalks nearby, so people walking or bicycling wouldn't have heard the water surfacing. I imagine that the tree roots had something to do with the failed PVC fitting. But this water essentially was flooding into the field. And according to the maintenance staff, this easily could have gone on for several weeks because they didn't visit the site very often, and they figured they'd probably find out about it when they got the bill. So when we take into consideration how long the leak would have lasted, minus the less than 48 hours that it did last, we estimate this saved over 900,000 gallons. And not only is the water wasted, we'll never get that back. This is water that we've captured and cleaned and treated and pumped and delivered. So the water's gone in a leak like this, but also it's thousands of dollars on the customer water bill, which is a unnecessary negative experience for them. So it's things like this that the data really paints a picture of how quickly a leak like this can unfold. The second leak example I have here occurred on a different meter and occurred in June 2019. Now you can see the bottom of the graph. I have the entire month of June laid out here, and you can see how the normal irrigation pattern repeats throughout the month, except for on June 19th, 20th, and 21st, there's a dramatic rise in use. So we're going to look at those 3 days. So looking at day 1 of the leak, Wednesday, June 19th, the normal irrigation happened at 1, 2, and 3 a.m. You can see that there. But then at 7 a.m., something happened, and it quickly rose to its max flow, so something failed there. This flow continued on through the end of June 19th for all 24 hours of June 20th. And you can see in the top left-hand corner of this graph box, the total use was over 32,000 gallons. That was just the leak. And then on day 3 of the leak is when I found out about it. I called the number associated with the account. They sent somebody out, and within a couple hours, they were able to shut it off and pause the leak. So you can see that the max flow on this one was about 22 gallons per minute, which, if that continues over a 24-hour period, is over 32,000 gallons per day. And we estimate on this one, if this would have gone on without AMI, gone unnoticed, it would have used over 600,000 gallons. But instead, we were able to limit it to less than 3 days. My third and final example occurred in November of 2018. In this case, the customer had decided to turn off the irrigation for the season, so the timer was in the off position, but some of the pressurized piping, something failed, and you can see something started there on the 2nd of November, and it flowed all of the 3rd, all of the 4th, and then when we notified them about it on the 5th, they were able to shut it down. So for this one, if I bookend the leak, you can see day 1 of the leak was a partial day, then it lasted those 2 full days, and then day 4 was also a partial day. So that is the kind of that leak window. But if we look at the potential leak, that dotted line across the top, that's what we assume would have happened. And in this case, because they were done irrigating for the season and they weren't doing their regular site visits like they do in the summer, this leak easily could have gone on for the rest of November and into December at close to 20,000 gallons per day. So that dotted line is the potential leak, and then that solid black line across the bottom is the water loss prevention. That's the water savings, which is, pretty impressive when you see these cases over and over again. Now for some takeaways. It's important to learn early on that AMI does not prevent leaks or prevent scheduling issues, but it can greatly reduce leak duration through early notification. So leaks and breaks are going to happen, whether it's aging infrastructure or accidents or the scheduling issues. This doesn't prevent that from starting, but it can greatly reduce the duration of it. AMI offers 24/7 leak detections if customers use the portal. Now, as I mentioned, we do weekly automated leak letters, but that's not 24/7. And we do phone calls and site visits, depending on the size of the leak, but that's not 24/7. The software for most of these portals is monitoring 24/7, and as soon as it detects a leak, it can send an email or in some cases a text message. If that information gets to the right person, then they can do something about it, and that's what really shortens leak durations. AMI is essentially a time machine. Now, it can only let you see back in time. They haven't figured out how to go forward yet. That would be impressive. But with this ability to gather this granular data, you can easily see a picture of the water use pattern going back hours, days, weeks, months. And considering our own meters, most of them are read 6 times a year, right, every 2 months. But with 15-minute interval data, which we get off from our AMI system, that's over 35,000 reads per year. When you lay that out in a graph form, that's when the patterns start to emerge. So I remember back for years I did water use surveys and irrigation audits, and I would often say, I can't go back in time. I don't know when the leak started. I don't know if there was a pattern to it. But with AMI, you can see that. AMI gets you the billing read, but it offers so much more. So I currently work in meter operations, so I mainly use AMI for the read, but going back to my water efficiency background, that's where I really learned the value on the customer side, what they can use with this data, and on the water provider side and how they can assist customers with this data, because we can learn so much about a property without even stepping foot on it. And finally, this can be used as a water budgeting tool. You can easily see who has a self-adjusting controller who was very proactive in scheduling throughout the year to follow that evapotranspiration curve. You can see who has a rain sensor, which irrigation sites are suspending irrigation after a rain. So I hope you found value in this presentation today, and thank you for listening, and thank you for your time.
Great. So I wanted to apologize. We had a few little technical difficulties there in the beginning, but hopefully this time around, everything will come up just fine. I just want to make a quick reminder to put your reactions in the chat. Any questions that you have, please put them in the Q&A. And with that, we will move on to the City of Sacramento and William Granger's presentation. William Granger is an advocate for both the water conserving benefits of AMI, but also river-friendly landscape transformation. He has over 26 years of experience designing and running water conservation programs up and down the state of California. For the past 8 years, he has served as the water conservation coordinator for the City of Sacramento, is a certified landscape irrigation auditor with the Irrigation Association, a qualified water efficient landscaper, and is a grade 3 water use efficiency practitioner, and has been a director with the California Irrigation Institute since 2007. He has a bachelor's in geography from the University of Florida and a master's in geography from the San Diego State University, where he started his focus on trying to better understand the constraints preventing the widespread adoption of water-wise landscapes. And with that, and hopefully no more technical difficulties, we'll move on to his presentation.
So the slowdown that
Sorry about that. It did not start from the beginning.
so a little bit of
Try this again.
Hello everyone, and thank you so much for the opportunity to talk to you about the City of Sacramento's AMI efforts. Much has changed over the last 8 years, and today I will share with you how we are currently using AMI data to notify our customers of potential leaks. We have made some recent changes, and I'll have a chance to highlight them with you a little bit later on. The City of Sacramento has over 141,000 service connections, and 98% of those are AMI metered. We have a fixed network with 270 gateways, and we expect to be fully metered before the end of 2022. Of those meters, We have a mix of 6-dial, 7-dial, and 8-dial encoder registers. That just means that we can see the smaller leaks. About half of our registers can show a leak that's about 18 gallons per day or 0.07 gallons per hour. So some pretty small leaks can be seen through about half of our meters. Customers can set up their own leak alerts. This is the screen that customers can see when they go in and create an account, which is free and shows you where they can set their leak alert. But unfortunately, only about 7% of our customers have created an account so far. And when our customers do create accounts, few of them realize that they can set their own leak alert, not have to wait for our letters to go out. So that's a different issue. What I'm going to talk to you about a bit more in detail is our automated leak letter process. So a little bit about our automated leak letter alert process. We worked very closely with our IT department to basically automate the leak letters and send them out to as many premise types as we possibly could. We had taken the information from Badger, which basically looks at it right now and what's leaking as of the last 24 hours. And we wanted to be able to take it and change the thresholds depending on the premise type. So if it was a single family or duplex, we might have a different threshold. Maybe we set it at 300 gallons per day and maybe 400 or 450 for a duplex. And maybe we had a different number of days of continuous usage before we generated a letter. So we wanted to set that process up. We tried to simplify it and get it to work. There's a little bit of compromise involved, like a lot of things. We end up sending out the same leak letter to all of our premise types. So it is somewhat generic. And the leak letters do go back out after 2 months if that leak still shows up and it's meeting the threshold at the time. So there are times where we've changed the threshold depending on staffing requirements. Maybe we're spending more time investigating water waste, or maybe we have a shortage of staff. We'll raise the threshold and not generate as many letters. And then 2 months later, maybe we've lowered the threshold back to 150 gallons per day, for example. So if they meet the threshold, they get another letter, and it shows up in our billing system that we send them a letter. And we used to get about a 20% response rate. Roughly 15 to 20% of the customers who got a leak letter would call us and request our free leak inspection. During COVID, it's been a bit slower, so that's one of our challenges, and I'll talk a bit about that a little bit later on. But we do send out leak alerts to about half of our premise types. So our irrigation only accounts, parks, pretty much you name it, we send out a leak letter to it, except for the more complicated, larger apartment complexes and larger commercial accounts. So I wanted to talk a little bit about our process over the last 7 years or so. So in 2013, our process was not automated. We would go in, we had a staff person go in, look to see if the leak was still showing up, and then click a box and the letter was sent the next day. So it was not automated. They had other things that they were doing. This was during the drought. And so not so many leak letters went out. We also didn't have quite as many meters that could be flagged for leaks. In 2017, you see a huge increase. That's because we worked with our IT department and they automated the process. And they set it up so that we could select different premise types and have different leak rates for each customer type. So we basically send out 2 different types of letters, a first and a second letter, and then the process repeats itself if that leak shows up 2 months later. So the leak shows up today, we send out a leak letter if it had been going on for 5 days. 2 months from now, we send out a slightly different leak letter. If that leak still meets our threshold, say 2 months after that, they get the first letter again. So it's not too customized. There's a bit of repetition, But you can see we've been sending out quite a few letters over the last few years, and we hit a record with 20,000 this last calendar year. The bulk of those letters that we send out do go to single-family customers, about 92%, and about 15% of those letters are to basically the second letters that I referred to. You also can see down here in the gray are the requests for our services. So roughly about 15% or so are requesting our services to go out and help find the leak. As I was showing on the last slide, we sent out a lot of letters in 2020, nearly 21,600 leak letters. And again, that was our record. But things started to taper off, and you couldn't really see that until you looked at the monthly data. So what happened? What happened in October, where we set our all-time record, and then we had such a huge drop-off in November? Well, there were a couple things that we experienced. So there were a few changes that we were hoping to make with our IT department. We noticed that there were some leak letters that we thought were going out, but customers weren't receiving them. And we also saw some leak letters that were going out when we didn't see that the hourly threshold was being met. So there was a little bit of a disconnect perhaps between us and IT as to what we considered continuous. And so they needed some time to write or rewrite the formulas. And we basically sent out a lot fewer letters in November. We didn't lose any staff and we didn't raise the threshold. It was because we just weren't generating quite as many leak letters. And we kept dialing down the leak threshold, but we still weren't generating all that many letters. The second change that I referred to was definitely more impactful in that we were generating leak letters only when there was continuous water use 24/7 for the number of days that we set. So for our single family customers, we have the threshold set at 5 days. And if that leak wasn't at, say, 6 gallons per hour, 24/7 times 5 days, no leak letter would be generated. What we found is that a customer had a leak, say 2 gallons per hour continuous. They turned on their drip system and decided to deep water their trees for maybe a day or two, but not for 5 days. And they got a letter from us. They had already turned off the drip system. The water use had dropped back down. Then they called us. So it was a bit of a waste of time as far as we were concerned. So the customer was aware of the water use and didn't need our service. So we felt that we needed to tighten things up, and that's what happened in November. So the slowdown that I showed you in those last couple of slides, we tried to make our adjustments and send out more leak letters by lowering the threshold. We lowered it all the way down to 75 gallons per day, which is just over 3 gallons per hour, but we still weren't generating all that many letters. So in January 12th, just a few days ago, we decided to make a process change, and that was to reach out to our largest and oldest leaks. We define largest and oldest as leaks that are using at least 10 cubic feet per hour and are ongoing for at least 90 days. We can look in Badger Beacon and see those customer types, and then we can reach out to them. And many of them have received letter after letter from us over the years. Our water conservation reps are now researching the history, seeing exactly how many letters were sent, seeing if there's a phone number on file, digging around to see if they can find some other contact information, calling if there is a number, and visiting the site, maybe leaving a door tag if no one's home, but trying to make that extra contact because these are really large leaks. This one, as you can see, was almost 800 gallons per hour before it stopped on the 18th of January. We are finding that many of these leaks are indeed in the customer's main line just after our meter. So sometimes your automated leak letters or notifications just won't have that desired effect. So given the shortage of calls coming in and availability of staff, this is typically our slowest time of the year, we figured why not have them drill down and look at our oldest, longest running leaks by customer type, and started with single family since it's about 92% of our customers. This is one of our very, very top customers, and they had received 19 letters since 2018. And actually, prior to 2018 and 2016, we had visited this house and left a door tag. The leak was a lot smaller, about 99 gallons per hour. And right before it stopped on the 18th of January, it was around 800 gallons per hour. So it had grown dramatically, as you can see there. That's just for January. We had called this customer and were prepared to go and knock on the door. Ended up reaching them at their place of business, and they finally found the leak. It was a mainline leak, and fixed it over the weekend. So as I mentioned, our current focus, given that we have the bandwidth or capacity to do so, is to reach out directly to our largest single-family customers with leaks and those that have had leaks the longest, and we figure we'll drill down. We have roughly 60 single-family accounts that have leaks larger than 75 gallons per hour or 10 cubic feet per hour for 90 plus days. So they've basically gotten our letters and not responded to them. And there's a variety of reasons for that. We figured we'd go that extra step. And then the next step below that are the leaks that are slightly newer, in quotes. There's about 143 single family accounts. So our plan is to continue to reach down, and as I mentioned, we just started doing this, but we've had some early success. You can see here that the leak did stop around 5 p.m. after the customer got somebody out there and made the repair. And a lot of these leaks turn out to be mainline leak repairs. That's what we found. They're so large that it's about the only place they can really be. Given that this is the California Irrigation Institute conference, I wanted to share with you some information about our irrigation accounts and leak alerts there. We have roughly 1,600 irrigation meters, and we're also drilling down to those largest leaks that have been going on for at least 90 days. A lot of those accounts tend to be or turn out to be the city, maybe it's a streetscape or park. So we're in the process of reaching out to those different departments, as well as accounts that are outside the city. Our automated leak notification program has really helped one of our programs that we call Leak Free Sacramento. It's a program that benefits disadvantaged community members, homeowners that live in the city that can't afford to make the repairs themselves. We have been focused more on outdoor repairs these days, and are working to get a second plumber and an irrigator if they qualify. And the big criteria is that they have to be a homeowner in the disadvantaged communities within the city, which is about half of the or they can qualify through our Sacramento Race program. If you have any questions, I'm happy to try to respond. Here's my contact information. Feel free to reach out to me, and thank you very much for the opportunity to present to you all. Thank you.
We will move on to our last but certainly not least presentation. I'm going to try and bring up the slide with all the tech specs one more time. Hopefully it will will work for you guys. Give me just 1 second. Connections that each agency has, as well as how many endpoints that they have overall. So let me try that one more time. I will leave that up while I introduce our next speaker, which is Debbie Pagoni with the City of Beverly Hills. So Debbie is an enthusiastic advocate for the environment with an extreme passion for educating people to use water efficiently. In her work as the Water Conservation Administrator for the City of Beverly Hills and in teaching water-wise landscaping workshops for other municipalities, Debbie has assisted over 12,000 residences and business owners to become more efficient water users. She has a BA in environmental studies and a master in public administration. She is a master gardener and has created award-winning landscapes that are attractive to people and wildlife. Debbie brings her experience to audiences in a fun, easily relatable way and empowers her residents, customers, students, and clients to use water wisely as they create and maintain their own landscapes. She feels blessed to be able to help people while also making a positive impact on the environment. And that she does. So I hear the slide is still blurry. So after the Beverly Hills presentation, we'll go ahead and bring it back up so that you guys can actually read it, and I'll have Steffi share that for you.
Yeah, and Jenna, the audio was a little choppy at the end for William Granger's presentation. So maybe I'll share Debbie's presentation. Just looks like
Perfect.
my internet is cooperating.
Yeah, better safe than sorry.
So let me bring this up. Just give me a minute.
And while Steffi's doing that, I'll just remind you, reactions in the chat box and any questions you have in the Q&A box, please. And our presenters will be responding to them as they can.
Good day, I'm Debbie Pagoni, Water Conservation Administrator for the City of Beverly Hills. My presentation focuses on how do you know what you can't see? AMI exposes it. After viewing some of the data from my customers' water issues, I often find myself making the Macaulay Culkin Home Alone face. In 2010, Beverly Hills began the installation of AMI with the Aclara Star system in an effort to improve meter reading and help customers manage their water use more efficiently. The initial AMI meter transponding units, aka MTUs, read every 6 hours. Now they read every hour. The data is now uploaded to the system every 6 hours. The City of Beverly Hills Water Department services all of Beverly Hills and half of West Hollywood with a total of 11,000 meters and one person, me, overseeing our conservation programs. When I got to Beverly Hills, they were driving their AMI system like a Pinto Ford station wagon, and now I drive it like a Tesla. We use our data to create 2 daily water leak lists, one with the top 100 residential continuous flow issues and one with the top 100 commercial flow issues. Note that not all continuous water flows are leaks, such as a running toilet or malfunctioning pool autofill. Either way, it's a waste of water and the city wants to mitigate these issues. I cold call customers with high water flows and send emails, texts, and letters to others. I encourage everyone to sign up for the city's customer portal program called Water Tracker, which I'll get into in more detail later in my presentation. I conduct about 30 audits a month with a 70% success rate for finding leaks and 100% for reducing excessive irrigation. I have been performing FaceTime audits for a few years, even before COVID. I find they empower the customer. As I mentioned, I'm a team of one. But along with my BFF, Amy, with an I, we solve mysterious water flow issues, explain high water bills, inform customers of water waste they can't or don't want to see, and we help our customers use water efficiently. I use the data to prove my case when I perform my leak and landscape audits, as well as use it to know how to target my outreach and focus my policies. I send emails to Water Tracker customers every few months. I send educational postcards twice a year, and create educational programs and flyers for my residents and their gardeners in English and Spanish. My flyers include how to sign up for Water Tracker, finding a leak, reading your meter, and my favorite, caring for your lawn and landscape, which I bring when performing a landscape audit. I also bring an irrigation controller spreadsheet, which I fill out with the homeowner and/or gardener. Beverly Hills has watering guidelines and mandatory rules in the municipal code. The one we strictly enforce are watering days, which change depending on the drought stage we're in. Presently, we're in stage C. Watering days are 3, June to September, and you can water 2 days a week, October through May. How do I know what I know? I know about the highest flow issues because of the 2 leak lists I get every day. When I work with customers on their leaks, I also make sure they're watering efficiently and doing the best they can. How are water issues exposed, you might ask? Well, with some detective work analyzing the data. I've worked on 8,000 cases, helping most of my customers find and fix their issues. In fact, many call me the Columbo of water leaks. By looking at the hourly data and the various patterns, I can typically tell what is irrigation, what might be a continuous flow, and what that flow might be. The number one cause of continuous flow issues are toilets. If your toilet's flowing enough that a squirrel can surf on it, that leak could be up to 200 gallons an hour. These issues are easy to find, and my customers are shocked and thrilled when we find them. Now that I've educated you on this fascinating fact, I'm going to focus the rest of my presentation on excessive irrigation and water issues in the irrigation system. This is an example of data from a residential customer who has a continuous water flow issue as well as excessive irrigation. I know this by the AMI data displayed in the charts. In this chart, each triangle represents 1 hour of water use. The consistent patterns represent irrigation settings. As you can see, the irrigation is on for 4 hours, 5 days a week, and the other 2 days it's on for 2 hours. Believe it or not, it's often the customers with the exclusive, expensive landscape companies that have this issue, and the homeowner doesn't realize it. In this slide, I'm highlighting how there was a reduction in the irrigation from week A to week B. If you look at the highest hour of usage in week A, it's about 200 gallons, but in week B, it's down to 1,900 gallons. Why? I believe it's because the gardener fixed a broken sprinkler head or pipe in the station or stations that go off during that hour. Finally, this chart shows when the flow started and when it stopped. It started on a Tuesday and ended on a Tuesday. The spike right before it started, as well as the spike when it ended, have a different pattern than the other spikes. This sort of pattern leads Detective Debbie Columbo to believe this flow is from someone leaving the pool or fountain autofill on. Often a similar flow like this is due to the gardener leaving a hose on for a solid week or 2. My job is to bring awareness to my customers, and I want to emphasize that every single customer I work with fixes their issues. The city also has a customer portal called Water Tracker, which was implemented in 2015. We have over 4,000 of our 11,000 accounts signed up. The customer has to sign themselves up, and I highly encourage everyone to sign up for this free program. The city gives bill adjustments for some water issues. In order to get an adjustment, the customer must fix their leak, the irrigation must comply to city code, and they must sign up for Water Tracker. My goal is to teach my customers how to fish, and Water Tracker is great bait. This customer was watering only twice a week in the summer. While it was about 17,000 gallons of water each time, they stay in their allowance or budget. I have allowances for all residential customers from the now defunct EagleView. Only I have access to this data, not the customer. But the customer does have access to the water usage features yearly, monthly, weekly, daily, and my favorite, hourly. If a customer has a continuous flow, they will be alerted via email or text. The red tips on this graph show the amount of flow. Placing your cursor over a day will display the amount of flow out of the total usage for that day. The customer also sets up their daily water budget. See the green line on the graph? This is based on their higher usage days, which are typically the days they irrigate. If they use more in a day than their budget, they'll receive an alert. One would have gone out on January 13th. This customer received a water tracker email alert that they had a continuous flow of 72 gallons a day for the last few days. In the meantime, they were watering 1 extra day a week this time of year, using about 2,800 gallons. Plus, they were watering 3 days a week during the rain. So, should they focus on the small leak or the excessive irrigation? I encourage and educate my customers to do both. Zooming in on a non-watering day, I can now see the water flow issue, which is about 1.5 gallons an hour. With more detective work, I can even see when it started and if it's getting bigger over time. When zooming out over the past year, I saw something this customer was doing that every water conservation person hates to see. No seasonal change in the irrigation settings. You know I'm going to set up an appointment to meet with their gardener, and the residents are going to be happy to have me do this. No one I work with wants to waste water, plus they're happy to save money. This customer showed up on my radar due to their continuous flow issue. In addition, they had daily irrigation. These two issues were wasting enough water every month to grow about 1/2 acre of rice or 150 pounds of almonds. Since the house was on the market, no one was living there. They were not aware. What I often hear from customers is that they didn't see anything and their landscape looks so dry, so I must be wrong. The meter must be broken or someone is stealing their water. Many calls and emails later, their usage and annual savings went down by about 60% without affecting the aesthetics of their landscape, and they're now true believers. I find persistence and support is necessary for true behavior change. The data and flow patterns are all different, but the way I go about working with my customers is the same, with patience, support, kindness, and guidance. What do you see here? I see excessive irrigation and 2 different stuck valve issues. This customer has 2 meters, one for indoor and one for outdoor. This is their outdoor meter. What do you see with this chart? While it appears they water every day, they have 2 settings, one for the front yard and one for the back. You can also see the day the gardener comes by the extra hours of water use around the 200-gallon mark. Because of the time of year, they should cut their watering down to 2 days per week. But considering the property size, they're not watering that much over their budget. Being able to read the charts gives you a sort of clairvoyant ability to see into the reality of the water use. Fortunately, people rarely doubt what I'm telling them. This customer had a broken pipe which grew faster than I'd ever seen. Luckily, they believed me and took immediate action. But as the data shows, initially they did not permanently fix their issue. Stuck valves are the most common outdoor issue, especially in drip lines. I've seen drip lines on for 2 weeks solid and the resident and the gardener had no idea. Some don't even notice puddles of water on the surface. Underground leaks are also quite common in Beverly Hills due to the older and larger homes. It's not uncommon for a resident to redo their entire house but not redo the plumbing for the irrigation system or the main line. Talking someone into believing me that they have an underground leak is challenging when it's not exposed. When they say, "I can't have a leak, I don't see it," I say, "How do you know what you can't see?" That's why I'm contacting you. My water's intuition believes it's a pinhole leak in a pipe, and I'm here to help you. AMI has many benefits. It provides information needed to reduce water waste, which helps the water agency, the owner, and the gardener. It alerts the customer when the issue occurs. They don't have to wait 60 days for their bill to arrive. It tells the truth about when water is being used, because not all gardeners water efficiently. And it tells you what you can't see. It's tough to make predictions, especially about the future, but AMI helps you. My job is my passion. My goal is to get all my customers to sign up for Water Tracker, educate all the landscape maintenance people about efficient irrigation, and make everyone aware of running toilets. This is my contact information. Thank you and have a water-wise day.
Thank you, Stephanie. All righty. So at this time, Steffi, if you could please put back that the text back slide up, and hopefully it'll actually come through clearly this time around. Also at this time, I'd like to invite our panelists to please turn on their cameras and their microphones so we can have a little Q&A chat. Steffi, the first question for John is kind of long. I'll invite you to go ahead and ask it. Hopefully that's clear for everyone this time around.
Yes, so do we have any questions from the audience first?
There was one in there that Deb already answered about how Aclara now provides hourly data or readings for her, and it's because of the system upgrade. I haven't seen any others.
All right, then I have a question for Don. Don, you covered somewhat that in the joint session, but in case people miss that, I'd like you to give us a sense on market penetration of AMR and AMI in California, if you could. Just rough percentage of urban customer accounts on AMR, AMI, maybe a rough percentage of CI customers that you think, even if maybe there is no solid data on it in California, that are using AMR or AMI system.
Hi, my video is still off.
Thea, can you fix that, please?
On it, one sec.
Okay. There we go. The short answer is I don't know the data for California. There are some reports out there that talk about it. My own impression is that California as well has a fair amount of penetration of AMR and AMI. It's probably less than the national average. So it might be in the 25% range for or maybe 30 for AMR, AMI, largely because the places where meters were inside, let's say New York City or Chicago or other places, had addressed those issues earlier, and California is a little slower coming to it. Now that the drivers are about conservation and water resource management, we see an awful lot of growth in California. And some of the older systems like San Francisco have been there for a while and proven it out.
Thank you. Jenna, do we have any, since I'm sharing the screen, I can't see the chat as easily. Do we have another question maybe from the audience? If not, Jenna.
One just came in chat and it's kind of long, so give me a second to quick scan over it and get to the question. It says regard to leak data versus ordinance provisions on fixing leaks. Now that you have data on frequency, duration, and consistency of leaks on residents who you've notified, what is your agency's thought behind the carrot approach and the stick approach in the most water conservation ordinance? The customer fixes leaks in a certain time period once it's found. I can repeat that, but I think basically it's the stick and carrot approach within your ordinance to kind of push leaks to be fixed within a certain time period. I don't know who wants to start. Debbie, you look ready to go, so I'll let you start.
So, as I mentioned, I work on a lot of these, about 1,500 a year. And I will tell you that 99% of my customers find it and fix it right away. You always have, like Willie was saying, he sent 18 letters to somebody. You always have the people that either, it's not that they don't care, they just aren't as proactive about things in their life. Having an ordinance so that people have to find and fix their leaks is helpful. We have something like that. But the time that it takes to actually get somebody to do it, your ROI on time is challenging because you also want to use that time to help find and fix other leaks. So again, I just want to reiterate that everybody I've worked with, not just Beverly Hills, but everywhere, no one wants to waste. No one wants to waste water, money. They want to feel good about what they're doing. It's just giving people the information, and in William's case, they even give them funding to fix it. Let's say they can't afford to fix an underground main line leak that could cost $10,000. So it's all about, I'm all about, carrot and teaching everybody how to fish and good bait.
Thank you. Craig or William?
Yeah, I'll go since I'm unmuted, I think, and I think Craig's still muted. One of the things that we've done recently is to prioritize certain kinds of water waste. So slip hazards, which are often, valves that are stuck on, or, you're going to see them in your AMI system. So that's something that I would say we actually still do take a carrot approach. We're just not quite as gentle. We're not quite swinging the stick, but maybe we're getting it. We're looking for it and getting it in our hands. Typically, we do give folks quite a bit of time, especially since we're not in an officially declared shortage. We're given a couple weeks, but with the slippage hazard and that potential to get a lot worse, we are a bit more proactive. But usually it's you notify them and you give them a heads up of, we're taking pictures and we're trying to get them to be proactive on their end.
Great. And Craig?
Yeah, and just a comment about Marin Water. We're still in the pilot phase for AMI with less than 10% of our customers with AMI technology on the meter. So at this point, we haven't altered our ordinance, but that came up during the feasibility study of definitely with that available data, limiting the amount of days that's eligible for a water loss adjustment. And right now, we're just using it more for education and for notifying customers of the leaks and encouraging them to sign up for the portal. But yeah, down the road, we would definitely consider ordinance changes.
One other thing I meant to mention is with COVID, I think all of us are kind of a lot more flexible. We're not shutting people off for lack of payment, but we have made a few exceptions. We got a complaint about a vacant office building just running nonstop. The water use was about 250 gallons per day, and then it went to 250 gallons per hour pretty quickly. Someone reported it to us, and we worked with our customer service folks and our first responders to go out there and shut it off. So we didn't wait 2 weeks. We didn't wait 5 days. We looked and found that there were several liens against the property, and they hadn't been paying their water bill, and we said, okay, we're going to shut that one off, and then they'll call us when they want it turned back on. So we've had a couple of situations like that, but normally we give them a bit more time.
We have another question that came through, and it kind of goes to a question that both Stephanie and I thought up as well. So this is really for, Don, you can weigh in on this one too, from your experiences. How do we move from using this technology to notify, educate, and assist customers to a system where customers get their own notification and take care of their leaks, i.e. teach them to fish? So who wants to start? Go ahead, Debbie.
Well, I love AMI. William was saying that some of his meters will detect slight flow issues. All mine do. So if somebody has 4 gallons a day, they'll get an alert, and then they call me freaking out when I have, many people that have 20 gallons an hour. I mean, I have a lot. And this isn't just Beverly Hills. Everybody, that has AMI knows a leaking toilet, easy, 200 gallons an hour. In fact, Steffi, was that a toilet that was running at your house? Or was it a drip line second one? So toilets are super common everywhere. And as Chris is asking, it's a great question because I get 20, emails, calls a day with people. I have, 4 gallons or 20 gallons a day. What do I do? Where is it? I called the plumber. And so instead of having people freak out about small things and spend a lot of money trying to find it, it's educating them on the proper steps to take to locate the issue, to worry about the real things. And it's very challenging. I do have a leak flyer that's helpful, and then I provide, kind of a list of the most efficient way to go about finding where this issue might be.
I'll comment. In my experience, which is broader based, more national than California, perhaps, utilities find that customers really want to be bothered when that has an impact on their bill. So if the leak's very small, even though it's there, but it doesn't have much of a financial impact, they tend to disregard it and see it more as a nuisance. So that's comment number one. And comment number two is the education process has to be more or less continuous. And anytime a customer calls the customer call center, speaks to a customer service rep, the first thing that should happen when the technology is there is a conversation about, you can see all this stuff online. And let me show you how. And this is just a continuous effort that takes a lot of cultural transformation on the part of call center folks.
All right, thank you. We have a few more questions coming through the Q&A module, which is preferred because then it's easier to differentiate between questions and comments. So a question from Amelia on the CII and large landscape accounts. Is there any assistance that the irrigation system flow sensors can add to leak prevention? Who would like to take that on?
I'll comment on that. So yeah, it's a flow sensor can be huge, especially when it's in conjunction with a master valve or some form of alerts. And for the flow sensors that learn how much gallons per minute, the flow rate of each valve, if that changes, then in some cases the master valve will close, or that particular valve will be suspended from operation until it's addressed. Some of the controllers notify the user, they're connected to Wi-Fi, and they notify the user of this high flow sensing. So I'd say it's separate from AMI, but it's becoming more common when people want to let their irrigation system kind of manage itself and just notify the user when something changes. So yeah, we're seeing that more and more on new landscapes going in, the use of flow sensors.
Anybody else from the panelists would like to comment on this question? All right, well, we have more questions coming through. There's one through the Q&A box for Debbie from Martha Rodriguez. Great presentation, Debbie. And great presentation, actually, all panelists, thank you. Can you elaborate, Debbie, on how you have been conducting virtual leak detection now and before COVID?
Yeah. For years, I've been doing FaceTime calls with people, and we have a lot of elderly people in Beverly Hills. The technology isn't something they were raised with. And so it empowers them to first do a FaceTime call. And then I have them walk around, I teach them how to flip their phone around so that I can see both sides. I take them to their controller. I have to show them what their controller is. I'm sure that Craig and William can relate to this. People don't even know, or Dawn, people don't even know what their controller is, their irrigation controller. So I take them to the box. I show them how to use it. I empower them to feel comfortable instead of intimidated with their controller, because it's common that what you tell your gardener or landscaper how to water, they're going to do something different or do what they want or just set it and forget it. And so I'll walk around. I'll tell them to find their shutoff valves. I'll text them pictures of what they look like. I tell them to take a screwdriver or butter knife, walk up to your valves, listen to them, see if you can hear water flow. So I give them everything that they can do, and to see if they can find the issue on their own. And a FaceTime call might take anywhere from 5 minutes to 20. And they're very, very helpful.
All right, we have another question in the Q&A box. This has to do with how the data is presented from Robert Hinkson. Has anyone found that presenting leak data in gallon per hour leads customers to believe leaks are worse than they appear?
I think Deb kind of hit on it. She has people that, freak out when they have very small leaks. I think we all do. So, people think a 75 gallon per day leak should be something they see, but if it's outdoors, there's almost no way that you're going to see it. So I would say that we kind of played around with the threshold, and that is definitely a challenge where the customer has a number in mind, but in reality, it doesn't necessarily translate on their water bill. And so we kind of play around with that number, and just started like I was presenting about reaching out to those that have maybe not responded to our letters. So so we've decided, hey, we need to be more proactive, not necessarily count on our letters to do that, and maybe not dial our threshold down quite as low as we could, but focus on those folks that maybe are paying their bills automatically and not looking at our letter. And I want to put in a little plug for SFPC. They do send out texts to customers, and so they have cell numbers for everybody, and I think Julie's on the call. So there's a lot of different ways to go about doing this. But yeah, that leak threshold is definitely something to keep an eye on, because it's going to be really hard to find that small leak.
As William was saying, and Vicki asked the question in the chat, Water Tracker will send out emails or text alerts depending on how you set it up. It's either or, and it typically will send them out the night. Like if you have a big flow issue, it'll send it out that night. So that can be incredibly helpful. Don was saying that in his experience, people don't care about small flows. I'm telling you, all my residents, all of them, and I have a variety because half of West Hollywood, we have, different parts of it. Everybody cares about the small ones. And even though sometimes in my head I'm thinking, I don't have time for this, 1 in 1,000 is a leak in the wall, is a pinhole leak in the wall. And so while I want to ignore these tiny ones, I don't want the liability because I'm always concerned about that. So it makes it very challenging to know about some of these things, because while you don't have time for it, you also don't want to, tell them you don't have time for it.
One other thing, I know it's an irrigation conference, but just the other day we found our largest toilet leak. It was 325 gallons per hour. So, I mean, that used to be the number that was reported by the California Urban Water Conservation Council is about the upper end of a toilet leak per day. So I think with AMI, we're able to actually check those numbers. And so, I mean, Deb was talking about virtual audits. That virtual audit question came up. We are still going outdoors when we find it's necessary, and some folks are challenged on the technology. But indoors, we're trying to do more of a virtual service. And we don't have the phones to do FaceTime, but we are trying to get them to check that toilet and tell them that, yeah, it could be a leaking toilet just because you don't see any water on the floor. It could be leaking. And I think that's a big challenge. People assume they'd see the leak. So.
And the flushometer is like 600 gallons an hour. It's crazy.
Thank you for that. And we have one last question, and we are at time, so let's just address this last question. It's through the chat. It's just to the panelists, so I don't think it's visible to the rest of the attendees. It's a question for Debbie. Does the water tracker system automatically text the customer if the system is showing a leak? I think Debbie said yes. And then the follow-up question, does the Badger Iron Water has this feature? Anybody know?
Yeah,
we have Badger, both Craig and I have Badger.
And with us, you can choose email and or text message, and you can have the user can apply multiple emails and multiple phone numbers. They're basically converting their phone number into an email, but it comes through as a text message. So their Ion Water portal gives them the instructions on that. Yeah.
Right. Ditto to Craig's answer.
Well, we are at time. Thank you so much to the panelists for the presentation, for attendees to have a lively discussion. It almost went without technical glitch. I hope that everybody got what they wanted from this, and I really hope we see you all next year for hopefully in person this time. This is a little too much, even me being on the younger side. I so much more prefer to have an in-person gathering. So hope to see you next year in person.
Thank you again to all of our panelists.